Yeah. Hello, how are you guys? Can you hear me? Hello?
Yes, we're good. I'm good.
Okay. So let's begin. Today, let me start by sharing my screen with you. Okay. I want to show you this week. This is the week. Now, the announcement you will see we have this is week 10. There's no classwork this week. No classwork, but there's a homework. It is due on Sunday that you have to complete. And that's it for the week. Of course, you know that you can access this by going to the models and scrolling down to the model 6, which covers week 9 to 10. Okay. Now, by now, I'm sure that you must have printed this statistical table and the procedure chart. I remember I mentioned that you should print them out since you'll be using them from the last week onwards. So now, let us begin. So today we'll start from the standard normal distribution. Now, all this time I've been showing you, I introduced you to normal distribution, to how to find the areas and probability under the standard normal curve. Now, let us look at the standard normal distribution and its application. Now, the standard normal distribution simply means a normal distribution with a mean of 0 and a standard deviation of 1. Now, all normally distributed variables, we can transform them into the standard normally distributed variable by using this formula that you can see, by using this formula that you are seeing on the screen. Z equals S minus mean over standard deviation, where X represents the data value, Z represents the standard score, mu represents the mean, and data symbol represents the standard deviation. So we use this to transform all normally distributed variable into the standard normally distributed variable. Let's do, for example, using this application. The application says the monthly utility bill in a city are normally distributed with a mean of $100 and a standard deviation of $12. A utility bill is randomly selected. A, find the probability that the utility bill is less than $70. B, to find the probability that the utility bill is between $90 and $120. C, to find the probability that the bill is more than $140. Okay. Now, how do we do this? As usual, we start by drawing the normal curve. So let me move this because this space is too small for it. Let me move it down so we can have enough room. Okay. Okay. Okay, we have enough room. No, right now we have enough room. Okay, now we can start with the first one. Part A says, part A. So the mean is, let me get, I think I wrote it down. So let me get to where I wrote it down. Yeah, make it easy for us. Okay, let me get it from here. The same, I mean the symbols. Okay. Yeah. Okay. So now we have mean right here. The mean for this question, we are given that the mean is $100. So I'm gonna put $100 here, and that the standard deviation is $12. $12 here. A says find the probability that the utility bill is less than $70. So in that case, our X will be $70. $70. So we're going to transform this using this formula here. And formula, I'm gonna copy this formula so I can see how we can use it to transform this. Okay, the formula right here. So equal, okay, all we have to do now is to plug in the values that we have. I'm gonna make this into 18. So it means x is 70, right? S is 70. So you got 70 minus mean is 100. Okay, divided by standard deviation of 12. 12. This so that gives us we can put it in a calculator. Let me write it down first, and then we can put it on a calculator. 70 minus 100 divided by 12. Okay. So we got 70 minus 100 divided by 2. So let's put that in the calculator. It says I have 70 minus 100 divided by 12. Negative 2.5. Negative 2.50. So we'll go and put it in there. Negative 2.50. Now, it is no longer X. It is now a Z. It is no longer 70. It is now negative 2.50, which means that the probability that the utility bill is less than 70 becomes, okay, the P that Z is a less than, right? It's a less than 70, less than, so I'm going to find less than symbol from here. Is less than negative 2.50. So, and to get that, we need to draw our chart. Yeah. So I'm going to draw it here. We got negative 2.50 and 0. Okay. Because this is say less than that. So we're gonna insert our line here, the x-axis, then put the bell curve. Okay. Then make this adjustment here. Okay, let's see right here. Right. Now put the center line. Sure. We put the center line. Okay, have it right here. Okay. Now, say less than 2.5. So we're going to put the line that represents 2.5, negative 2.5. then you say less than that. That means you're gonna shed less than that. As a matter of fact, to shed it faster, I can use this. Okay. Okay. So now, having drawn this, now let's go to table, but let's look at the procedure chart. Okay. The chart that looks like this one is this one. You can see that this one. What they say is at the tail. Okay. As you can see from the screen, this one looks like that. This one here. And it says, look at the z value to get the area, subtract the area from 0.5. Okay. Now we can now go to the table. We are looking for, what we're looking for is the area that, or the probability for this. So the type of table we are using, remember I mentioned this earlier before in this class, the table we are using is this type. I mean, if you know how to use the one in the homework, you can still use that one, but the rules the rules for that one is different from this one. Right now, this one, remember that our looking for negative 2.50. For this particular table, negative sign simply means that it is on the left side. That's all. So if you're looking for this using this table, all you have to look for is for 2.50. So you have 2.50, 2.5. See 2.5 here under 0. See under 0. And see 2.5. 0.49. You can see 0.49 0.4938. 0.549, 0.4938. Okay. So based on that, this rules said that we should subtract 0.5. Subtract the answer area from 0.5 because when it's in this type, then that's what we're gonna do. Now, in that type, we call it a tail. See? We call it in the tail. Okay? And that is the tail right there. It's appear in the tail. See, this is the tail right there. So that means we're gonna do 0.5, 0.5 minus answer we got from the table is 0.4938. And that will give us the probability we're looking for. So I'm gonna write 0.5 minus that, 0.5. Okay. So that one we can get from the calculator. 0.5 0.5, 1 minute. 0.5 minus 0.4938. Give us 0.0062. 0.0062. Okay. 0.0062. Let's go and put it on the calculator. 0.0062. Does anybody have a question on this? Any question? Okay, good, excellent. Now, part B says, find the probability that the utility bill is between 90 and 120. Now, in this case, we have two numbers. So we have to transform these two numbers. Okay. Again, remember that the mean is still the same. The mean is still this 100 and the standard deviation is still 12. So have mean, that's part B. Okay, we still have the mean. 100 and standard deviation is 12. Now, again, we have two x's. Then we have 90 and 20. So we're going to have x1 equals 90. And we have x2 equals 120. So we can now get our transformation. Remember, just make some small adjustments here. Okay. More adjustment here. So now to transform this, we need the formula. That same formula here, modified a little bit. So to get this, I'm going to write this thing down, and we can go to the other workbook and put it the right way. We have the mu1, mu is 100, standard deviation is 12, x1 is 90, x2 is 120. So let's go to where we can get the formula correctly and use it to transform it. Okay. So I'll take you to this workbook, which will allow us to put the correct formula there. So I'm gonna insert the formula. Okay. So we have it in this form. We have z1 equals, make this thing big. Let's make it 18. 18, it should be good enough. Z1 equals, we have x1 minus mean. I can get the mean from here, divided by the standard deviation. Okay. Which is equal to, now we can put the numbers. Remember that our numbers are as follows. Mean is 100, standard deviation is 12, and S1 is 90. So that means we have putting those numbers in 90 minus 100 divided by standard deviation of 12. Okay. So I got Z1 equals 90 minus 100 divided by 12. So let's put it on the calculator. So we have 90. Gotta move this down. So I got 90, okay, minus 100 divided by 12. Okay. 90 minus 100 divided by 12. Give me negative 0.83 rounded. Negative 0.83 when you round it decimal places. So we're gonna put it right there. Negative 0.83. I'm gonna copy this and put it here. Okay. Now the other one will be so it is no longer x1, it is now z1, and it's no longer 90, it is now negative. We have transformed 90 into negative 0.83. So let's transform x2. The same process. So this time around we use z2 equals to 120 minus 100. What 12. Okay. So you got z2 equals x2. So it's 120 minus 100 divided by 12. So let's go and put it on the calculator, see what it will give us. So you got 120 is 1.67. We have 1.67. Okay. 1.67. Can go and put it in. Yeah. 1.67. And we can copy this. Then paste it here. So it is no longer x2, it is now z2, and this 120 has been transformed to 1.67, which means that the probability that the utility bill is between 90 and 120 becomes the probability between negative 0.88 83, okay, less than z, okay, I mean between z and 1.67, less than 1.67. That's how we write between z equals negative 0.83 and z 1.67. So to find that, we're gonna make a chart. Okay, you can draw the chart here. You can draw it here. Yeah, I think we can draw it here. We'll have negative 0.88. We got 0. Oh, 83. Got 0. Then you got 1.67. Okay. Now we can put the lines from here. Okay. So I'm gonna put the line on this spot to that spot. Okay. Then we can put the bell curve right here. Okay. So now we put the center line. Say between these two numbers, I'm going to put the line that represents them between negative 0.83 and 1.67. And it says between them, right? So we're going to share between them to show the full picture. So we're going to share between them. So I'm just going to share this. Okay. So that now we can now have the check the procedure chart. And you can see that the chart that looks like that one is this one here. So you see this one. Okay. And for that one, it says look up the z-value to get the area, add the areas. Yeah. So that means we're gonna get the areas and add them. So we get the area for 0.83 from the table of normal distribution. 0.83. Okay. 0.83. So 0.8 right here, it go under 3. See 3 right there. 0.8 under 3. I got 0.2967. 0.2967 plus. Now, next thing is to get the other one, which is 1.67. So you go check 1.6 under 7. 1.6 right here. You go under 7. See, under 7 right there. 1.6. 0.4525. 0.4525. When you add them together, that'll give you the answer you're looking for. So that means we have for this one, we have from the table 0.2967 plus for this one, we found that it is 0.4525 on the table, of course. So we thought this should be on board. So now let's add this on the calculator, we get our answer. According to our calculator, we have 0.2967 plus 0.4525, 0.7492. 0.7492. So that's the correct answer for the required probability, which is the probability that is lie between $90 and $120. It'd be 0.7492. Now, any question before I go to the last one on that section? So no question, good. Now let's look at it, part C. Part C says, find the probability that the utility bill is more than $140. So again, we have all our information. Mean is still mean is get it right here. Mean is still hundreds and standard deviation is still 12, but this around S is 140. Super C. Okay. That case, X is 140. So we're gonna transform X. So we're gonna use this formula to the same formula. So I'm just gonna copy it from here. Okay. Okay, I'm gonna copy it. Now come down here and paste it. Okay. That means we're going to transform it. So you got S is 140 minus 100 divided by 12. So I got 140 minus 100 divided by 12. So I got 140 minus 100 divided by 12. 140 minus 100 divided by 12. 3.33. 3.33. So that the probability that that the utility bill will be more than 140 becomes the probability that it will be Z, because now it is changed from X to Z, and then 140 is now transformed to 3.33. So more than means greater than, because it says more than 140. That means greater than. So you have, we're gonna put the greater than symbol here. So find the symbol and put it right there. Okay, more than 3.33. Okay, that will give us, first to answer this, we need a chart. To make the chart. Got 0. Got 3.33. So let's put the line, the x-axis. And then we put our bear curve. Okay. Okay. Then put the center line. I'll move the center line a little bit. So we're gonna put the center line. Okay. The center line should be inserted. Okay, this is it. Now it's on the side. You're gonna move to the center. Okay. Now we put the line for the 3.33. but it says greater than. So we're going to share the part that represents greater than. So it means here. Okay. Now, we are ready. Now, next is to look at the chart, the procedure chart. Okay. For the procedure chart, you found it right here. You will see that this chart that looks like that one is this one here. This one. See? This one right here. So on the tail. See, look at the z value to get the area. Subtract the area from 0.5. That's what it says. Okay, our z value is here is 3.33. So we're gonna do 0.5 minus, now let's find the value for 3.3, z value for 3.33. The area for 3.33 from the table of normal distribution. Okay. Have 3.33. You see 3.3 right here. 3.3 under 3. And see all the opposites under 3. All right, 0.4996. 0.4996, right? 3.3 under 3, right? I think that's what we have. Make sure, just make sure, making sure. 3.33, and if you look at the calculator, make sure that what we have. Yep, 3.33. So look under 3.33, 3.3, we go under 3. See, 3 right here. So 0.4996. Got it? So we go and put 0.4996 right here. 0.4996. So we have 0.5 minus that on the calculator. We have 0.5 minus 0.4996. So you see, you give us the answer in scientific form. You say 4 times 10 to the power negative 4. This negative 4 here means that there's going to be 4 zeros before the first significant digit, which is 4. So that's going to be 0.0004. So answer will be 0.0004. Okay. Any question on this one? Yeah, good. Good. Excellent. There's no question. That's good. So that's how you apply probability, normal distribution, use normal distribution to solve the table to find the different probabilities. Now let's look at since there's no question, let's look at the next thing in line. I mean, maybe you can try this one as a practice for yourself at home. So let's try this. This one, it says finding values giving specific probabilities. So in this case, we need to find the value of x. That's what, unlike before when we are looking for z and use it to find the probability. But this time around, we're trying to find the value of x. We are given that we have values for standard deviation and mean and z. So in that case, we use x equals z times standard deviation plus the mean, where s, of course, is the data value we are looking for. Delta is the standard deviation. Mean is the mean. Mu is the mean. Of course, z is the standard score. Now let's apply this to this question. It says to qualify for a police academy, candidates must score in the top 10% on a general ability test. They must score on the top 10% in a general ability test. The test has a mean of 200 and the standard deviation of 20. find the lowest possible score to qualify. Assume that the test score are normally distributed. Okay. So the lowest possible score to qualify can be found using this formula as equals z times standard deviation plus the mean. Now remember that our listing. Let me see. Oh, excuse me. Our mean is given. Let me get the symbols from the last work we did. The mean and standard deviation are given, right? S is what we don't know, and that's what we're looking for. In this case, the mean and the standard deviation are given. I'm gonna okay. I'll move this down. The mean is given as mean is given as 200, and the standard deviation is given as 20. And it wants us to find the x, which is the lowest possible score to qualify. But remember that to qualify, the candidate must score in the top 10%. Top 10%. That means their score will be bigger than 90% of people who took the test. So let me show you how it will look in a diagrammatic form. I have our 0, okay. Looking for z here, right? To be able to solve this, we need a z to be able to solve this. Okay. And this. Let me make it like this. So you have to solve it, we need to get our z first. And to get our z, we're gonna draw the chart first. Look at the chart. It looks, and then put our bell curve. Okay. Okay, we have our center line. Okay. Now looking for, say, top 10%. I mean, this is they call top 10%. Matter of fact, look that way. Okay. Okay. Top 10%. Gonna be, so here, let me share this first of all. I'm gonna share it out, Gonna be here. Okay. This is top 10% is right here. See? Actually, right here, not here. This is it right there. It is right there. Here. Okay. That's it right there. That's this line here, represent top 10%. Let me move the Z back to backward to that line. See? Now, so we want to find it, we need this form, we're gonna use this formula, but we need to find this Z first. Top 10% means that the rest is 90%. From below is 90%. So our Z is going to be here. Say Z equals. Remember when we're using for the procedure chart, we know that when it's at the tail, we're gonna do 0.5 minus 10% is 0.1. Okay, which is 0.400. Okay. 1 minute to mass. Okay. 0.400. Now we leave a 0.400 inside the table of normal distribution. 0.400, you can say 0.4000. We put it right here. 4000. We don't have it. If you don't find it exactly, if you don't find 0.4000 exactly, use the one that is closest to it. So I got this 0.4015, 0.39997, and 0.4015. These are the numbers that are close to it. Let's test this one. Okay, ignore the decimal point and do 0.40 means this is remember, this is 3997. I'm right here, 3997. Okay. 3997. So 4000 minus that. Okay. Let's see how many points away it is. Okay. 4000 minus 3997 is 3 points away from 400. Okay, from 0.40. Okay, let's test the other number, the other value we found there, which is 4015. Okay, now 4015. 4015 minus 4 is 15 points away. I mean, this one is far away. The other one is closer. Okay, because it's only 3 points away. So that means 0.3997 is closer because it's 3 points away. You follow it to the left, which is 1.2. Okay, and up 8. So you got 1.28. Z is 1.28. Now with this, you can now calculate the lowest possible score to qualify. So that means the lowest possible score to qualify is, can say that the lowest possible score to qualify is given by, we have the formula as x equals, oh, excuse me. Okay, so I'm gonna copy this and paste it here, the formula right here, which means we have our x, z, our z is 1.28 times standard deviation of 20 plus the mean of 200. And that will give us the lowest score to qualify. Let me put that down. I got 1.28 times 20 plus 200. So let me go and put this on the calculator. Okay. On the calculator, I got 1.28. Oh, excuse me. 0.28 times 20 plus 200. 225. 225.6. So that the lowest possible score to qualify, so as the cutoff point is 225. 225.6 as a matter of fact. So that is the lowest possible score to qualify for this academy. Any question on this? Any question, guys, for me on this? Okay. So no question. Excellent. Now let's try another one then. Since there's no question. This one says, for medical study. Now, a researcher have to, he wishes to select people. I mean, the participants. Wishes to select the participant in the middle 60% of the population based on their blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people to participate in the study. So first thing, of course, is to write out the summary statistics we have. So that the mean is 120 and the standard deviation is 8. He said he wants to select people in the middle 60% of the population. And we're looking for the upper and the lower reading, upper readings, the upper and lower readings to qualify. Okay, so let's that means we're gonna get, we need our x1, okay, and then we're gonna get our x2. So now, first of all, let us draw the chart. See, because it says middle 60%. Okay. Middle 60%. So you're gonna have Z1, negative Z1. Just call it Z1. You got 0 and Z2, of which Z1 will be, we don't know yet. Okay. So let me just make this adjustment. And we go from there. So we have Z1 and Z2, sent to X1 and X2. Okay. So we can put the bell curve. Let's draw the x-axis first. Okay. Middle 60%. I'm just gonna use some blood pressure. Okay. Let's put the bell curve. Okay. Then you're gonna put the center line. Middle 60%. So you're gonna have a Z1 here, and our Z2 here. So because they say the middle 60%, we're looking at 30% on both sides, right? Okay, this one doesn't want to stand straight. Stand straight. Okay, good, got it. So let's so I mean we're gonna have 30% here. 30%. Okay. On the left side. And on the right side, another 30%. Make it middle, two of them make it 60%. Middle 60%, and it's at the middle. So that means I'm gonna share that those in between those two places. Okay. I'm gonna share it. Yeah. Yeah. Okay. Share it. So now let's find out Z1. So the total that is 60%, half of which is 30%. Now, I mean 30%, which is for Z1, 30%, which is 0.3. But it's usually numbers in the table have 4 figures. So we're going to 0.3000. And let's look for 0.3 on the table. Okay. 0.3 on the table. 0.3. If I don't find it, I will just choose a number that is closest to it. I got 0.300. So I got 2995 and 3023. This one is bigger because it's 23 points away. So it's more far away. So you choose one that is closer, which is 2995. So let's see how close it is. So say 3000 minus 2995. I mean, when we ignore the decimal points, it's only 5 points away. Whereas the other one, which is 3023, we check it. See 3023 minus 3000. 23 points away. So it's far away. The other one is closer. So we choose the one that is closest. That means this one here. 2995. Follow it to the left. 0.84. 0.84. So you have 0.84. Now, because Z1 is on the left side, we're going to make it negative 0.84. Now, Z2 is on the right side. By symmetry, Z2 will also be 0.84 by symmetry. But because it's on the right side, it's going to be positive. I'm going to make it Z2. Okay? Z2. Once we have this, remember the question wants us to find the upper and lower readings. Find the upper and lower readings. So we have our S1 and S2. Sorry, Z1 and Z2. So we use to find S1 and S2. S1 will be, remember the formula, Z1 times standard deviation of, let me get the standard deviation from, right here. All right, I can just put it for you. Get the standard deviation from here. Okay. Standard deviation of this plus the mean. Okay. And the mean symbol is right here. Okay. Right here. Yeah. Okay, put it right there. Now, this will be our X1 formula. Now, our S2 formula is the same thing, but this will just change the X1. Okay. So change the 1 to 2, that's all. Okay, I'm going to change this to 2. Change this 1 to 2. Z2. Now, Z2. Okay, same thing. So I'm going to just copy this, so we can get X1 and X2. So we have, so S1 now become equals, excuse me. Become equals, Z1 is negative 0.84. I gotta make sure you're seeing this. Yep. Negative 0.84 times standard deviation of 8 plus the mean of 120. And that will give us the answer for that. So I'm gonna write this down so you can get it from the calculator. We have negative 0.84 times 8 plus 120. Okay. So let's just go and put this in the calculator and we'll get our answer. Okay, we have negative 0.84 times 8 plus 120, which is 113.28 millimeter of mercury. So I'll write it as a lower reading. So lower reading X1 which is our X1 is 113.28 millimeter of mercury. And the upper reading X2, upper reading X2 equals the same thing, but this around there won't be any negative sign, but a positive sign. Equals. So I'm gonna just go to the calculator and remove the negative sign. Okay. That'll give me 126.72 millimeter of mercury. So anybody within that 60%, whose blood pressure fall within this range, will qualify for the study. Okay. So anybody within that age, which blood pressure is within that range, will qualify for the study. Any question on this?
No.
Okay, good, excellent. Now we can look at another way this question can be asked. It says, suppose SAT scores are normally distributed with a mean of 950 and a standard deviation of 200. Compute the 95th percentile score. Okay. We are given by that the mean is 950 and the standard deviation is 80. And the 95th percentile score, X. Okay. Let me put it this way. The 95th percentile score is the score X such that 95% of all the people that all the scores are below it. So whoever have that score perform better than 95% of all the people that do the test. So which means that the 90th percentile score is the score X such that 95% of all the scores are below it. That means. So having said that, let's look at how we can get it. Let's start with the chart first of all. So that means 95th percentile score is almost like it's just like saying the top 5%. Top 5%. Let's put that as Z right here, right? Okay. We can make our chart by putting this. Okay. I got x-axis. Okay, we got the bear curve. It just makes some adjustments here. Okay. And bring this. Okay. Now bring it back more. All right. Now we can put the center line. I'll put the center line here. Let us put the center line. And then we put the Z line so that we're talking about this area. Okay. Now,
if you're looking for
huh? Top 5%, that's what we're gonna do. Top 5%. That's gonna that's top 5%. 5%. Because 95% of all the scores will be below it. That's just the line right there. So you have that about that 95% will be below it. Okay. So that we have this in the form. So that means 95% test score. Let's find our Z first of all. Let's find the Z. Okay. To say 95%, that means it's at the tail. That we're gonna do equals 0.5 minus 5%. That means minus 0.05. Okay, that gives us from the calculator 0.5 minus that 0.5 0.5 minus 0.0500 0.45 0.4500 okay 0.4500. Let me go and write it down. 0.4500. Now we look for the table, the Z value that corresponds to that. Table Z value 0.4500. I saw two of them, 4495 and 4505. 4500. Let's say which of them is closest. Let's say let's test 0.49495. We test it with what we have. We have is 4500. See 4500. Let's try ignore. Let's assume that there's no decimal point. So we have 4500. So we go to a calculator. 4500 minus 4495. See, 5 points away. That's 5 points away. Okay. Now let's try the other number, which is this one here. 4505. 4505. Okay. So let's try this that one. 4505. 4505 minus 4500. It's still 5 points. So they are equally close. Two of them are equally close. They are both 5 points away. When that thing happens, when this happens, choose the bigger one, which is this one here, 4505. And when you follow it to the left, from here to the left, 1.6. Go up 6. So you're gonna be 1.6, actually 65. It's gonna be follow it to the left, it's gonna be 1.6. If you go up, it's 5. So 1.65. 1.65 is our Z. 1.65. Z is 1.65 from the table. Okay. Now we have our Z. We can now find remember, say the 95th percentile score. The 96th percentile score now becomes, this is the formula we use. And this formula will give out equals Z, which is 1.65. Okay. Times the standard deviation of 200 plus the mean, which is 950. So I'm gonna have 1.65 times 200 plus 950. That'll give us the X we're looking for. So we have we now proceed to our calculator to put this in the calculator. Okay. So we got 1.65 times 200 plus the mean of 950. 1280. 1280. 1280. I mean, it's 1280. So that means this is the 95%. So anybody who have this score perform better than 95% of all the students that took that SAT test for that season. Does anybody have a question on this? Any query? Okay. Good. No question. Good. Now, let's round up with what we call the central limit theorem. Central limit theorem, what it's talking about is that if you have a population with a mean mu and standard deviation, okay, we have that kind of population, a large population with a mean and then standard deviation delta. It is saying that if you take sufficiently large random samples from that population with replacement, then then it means that instead that as a sample size increases and approaches infinity, then the distribution of the sample mean approaches normal distribution. In other words, when the sample size increases, so long as it is the sample are taken at random from the population, the sample size increases, then the sampling distribution, the distribution of the sample means will become normalized. Okay. So at that point, the sample mean will be equal to the population mean, and the standard deviation will be equal to the population standard deviation divided by the square root of the sample size. So to use the central limit theorem, we modify our original formula and write it in this form. This is the new thing we'll be using for the transformation, where S bar is the sample mean, this is the population mean, this is the population standard deviation, and this is the n, root n, square root of n, which is, and n is sample size. So this is the new thing we use to transform. Okay. So let's apply it to this situation. Okay. Now, for this, this means that if you want to, this is the formula for transformation. Okay. Now also, if you want to find the standard error, okay, we use this one. See, standard deviation divided by square root of n. Assume that that's what we want to find it. Now, let's apply this to this question. It says here, the Nelson, let me see, let me choose which one shall I calculate? Okay. Let me solve both of them. See, AC Nielsen, this is for those of you who haven't heard of AC Nielsen, I think is a company that conduct polls. Let me see if I can pull it from here. I don't know if I can pull it from show you. AC Nielsen. Anyway, they do polls, like you have political polls, stuff like that. So AC Nielsen reported that children aged 22 to 5 watch on average 25 hours of TV per week. Assume that the variable is normally distributed and that the standard deviation is 3 hours. If the 20 children between the age of 2 and 5 are randomly selected, calculate the standard error of the mean. So anyway, remember I said the formula is this one. Delta, maybe I should make it bigger. See, okay, I'm gonna make it larger. So expand it more. See, standard deviation by the square root of n. Maybe I need to get a better one from the other workbook. Now you're gonna be standard deviation over square root of n. Now I'm gonna get it from here, the other workbook. So you're gonna be standard error, standard deviation of X bar. Now X bar is right there. Okay. That's standard error. It's gonna be equals, excuse me. We got standard deviation over the square root of n. So that's the standard error. I can find the standard error. Standard error equals standard deviation over the square root of n. Okay. So that's how you're gonna look. So I'm gonna put it right there. So we can have it right there. The question says calculate the standard error of the mean. It's the formula right there. Which means that our answer will be make it 18. Our answer will be equals to the standard deviation divided by square root. This is the standard. We are told that the standard deviation is 3 and n is 20 children who are selected. So I'm going to go back and put it 3 over root 20. Okay, which is 3 over the square root of 20. Okay. Okay, that will give us the standard error. So this we can get from the calculator. 3 divided by the square root of 20. 0.671, around that, 0.671. 3.671. We round it. That's what I got. Okay. 0.671. Okay. All right, let me copy this. Like the standard error. That's how to, if you ask to find the standard error of the mean, that's all you need to do. Divide the standard deviation by the square root of the sample size. Any question on this one? Okay, no question. So now let's look at the application of the central limit theorem. Using one question here. It says there is a large supply of special energy saving light bulb with the average life of 890 hours and the standard deviation of 50 hours. A random sample of 49 light bulb is drawn. Calculate the standard error of the mean and then find the probability that the sample mean will be less than 1,000 hours. Assume that the lives of the light bulbs are normally distributed. Okay. So you start by, of course, writing your solution. Solutions. Okay. Now I'm going to make this to be 18. Font size 18. Now, you see that, let me get the characters. N is, okay, N is sample size we are given. We get these characters here. Okay, have this. This for part A. N is 20. N is say there is a large supply of special energy saving light bulb with the average life of 890 hours and the standard deviation of 50 hours. A random sample of 49 light bulbs, 49 for N, with a standard deviation of 50 hours. We have to find a standard error of the mean. Thus, it means standard deviation divided by the square root of 49. You're gonna be this standard deviation of 50 divided by square root of 49. And that will give us 15 from the calculator. 50 divided by the square root of 49. 7.14 rounded. 7.14 rounded. 7.14. So you're gonna copy this. That answers part A. It answers part A. Okay. Right. So now we can now answer part B. Part B says find the probability that the sample mean will be less than 1,000 hours. So you get our N again, part B. And let's get the variable, the summary statistics we are given. N is 49, standard deviation is 50. Then the mean, sample say that there is a large supply of energy savings light, but with average mean of 890 hours. So mu is 890 hours. We get this character for mean. Yeah, it was I had to get it from here. Okay, the mean. Okay, we say mean. Okay, so that is the population mean is here. So it is 890 hours. And then the sample, then you say that assume that a random sample of 49 light bulbs are drawn. Find the probability that the sample mean, which is, that means will be less than 1,000 hours. The sample mean will be less than 1,000 hours. So the sample mean is gonna be 1,000 hours. So you're gonna get it. I can't get the character from here, so I'm gonna get it from here. Something is x bar, which is 1,000 hours. Okay. 1,000 hours. Well, at the hours. Now, we can now use this to find the probability. We have to probability by transforming this sample mean using this formula for this transformation formula for central limit theorem. I use this. This is the formula we're gonna use. Okay, let me write it down here. So I'm gonna write this information we have about the sample mean. So we have that the x bar is 1,000. Sample population mean is 890, as you can see from the screen. Okay, 890. N is 49, subsample size is 49. Standard deviation is 50. Let us go and get this from the calculator. Put this formula in, and get, so we can get it from the other workbook. So this one will not allow us. So I'm gonna put it right here. Okay. Make this to be 18. Unbold it. Make sure you are seeing it. Okay. Why is it doing this? Okay, since it's doing this, I'm gonna type it manually. It's giving me trouble. Let me type it manually. Okay. We got that okay, let's see. Why is it doing this? Okay. No, I don't want this. This is what I want. Z equals, I'll make it 18. Okay. Equals okay, put this. Sample mean x bar minus population mean mu. Okay, divided by standard deviation. I'm gonna put this delta. Okay, about the square root of n. Which means we have this. Sample mean is 1,000. Population mean is 890. Divided by the standard deviation of 50. What is square root of 49 samples they're taking. Of course, you know that all this are from here, from the problem we were given. Say that population is 890 hours, and the standard deviation is 50 hours, and the random sample, which is n of 49, and they say find the probability that the sample mean will be less than 1,000. So you can see where we get those numbers, and I also listed them here. Okay, so let us find the result from this transformation and calculation. So I got let me write it down. 1,000 minus 890 over 50 root 49. Let's do this one. Let's go and put it on the calculator. You go to the calculator and have okay, we got 1,000 minus 890. Okay. Divided by the standard deviation of 50 over the square root of 49. 15.4. 15.4. 15.4. I got 15.4. Okay, it's not always like this big, but this is just the, of course, from the other ones we solved, we know that it's not always like that. I'm gonna copy this and paste it in the manual book. Okay, 15.4. So it is no longer x bar, it's now a z, and it's no longer 1,000, it is now transformed to 15.4, which means that the probability that the sample mean will be less than 1,000 becomes the probability that, excuse me, that, I'll make this 18 and times new Romans. Okay, become this probability that z is a less than, right? Okay, less than. So I'm gonna put less than here. Z it's less than. Okay, we put less than right here. Less than 15.4. Okay, which is equal. To answer that, I'm gonna make a chart. Okay, let me make a chart here. From here. Or maybe I can make the chart on this side here. So now it's possible. I can make it on the side here. I got 15.4. Oh, excuse me. 15.4. Let me make them big so I can, you can see it. 15.4. We have 18. Oops. I'll make it 16 then. Okay, I'm gonna just move it backward. Okay. Now I can put my chart. Remember, this is 15.4. Okay. Now let's put the chart. Make sure. I got the x-axis. Then I'm gonna put this. Okay. All right. All right. Okay. And then I'm gonna bring this back. So put the center line like before. Now the center line, which is right here. Then put the line that represents 15.4. Okay. Now you can shed it. This is represent greater than 15.4. Okay. Now, from the normal distribution table, we know that when it's at the tail, we're going to subtract from 0.5. So 0.5 minus, let's look for 15.4 on the table. 15.4. Well, unfortunately, we cannot find the highest number we have here is 3.6 for Z. Now, remember, but it says here, let me make it bigger. It says, I hope you're looking at this. Say for Z values greater than or equal to greater than 3.7, use 0.4999. And you can see from here, it's off. Anything bigger than 3.6 is 0.4999, all of them. Okay, 0.4999. So we're gonna use that 0.49. Each time you find a value that is bigger than that, use 0.4999. Oh, excuse me, 4.999. Okay. 0.5 minus that. So you got 0.5, 0.5 minus 0.4999. See, you gave us the answer in scientific form. Say 1 times 10 to the power negative 4. This is a 10 to the power negative 4, which means that there are going to be 4 zeros before the significant digit 1. So the answer will now become 0. This is the first zero, second zero, third zero, fourth zero before 1. See? That is that there's a slim chance, very slim chance that that's very slim probability that the sample mean will be less than. Oh, you know what? My mistake. I made a mistake. He said less. I did greater than, right? Yes, sorry, my mistake. That was wrong. I did the wrong thing here. See, this is for greater than, not less than. So if it's greater than, if it's less than, I'm going to share the right place. So let's see. Let me see. Get the eraser from to erase all this. Okay. Because I did right. See down. All right. Now what you're gonna do now is say less than. So a mistake. Yeah. Say less than. Say look. This is the line. Back this way is less than. This way. Not this way is greater than. This one is less than 15.4. So say less than. So what you're gonna do is to share the right place. Okay. Let's share all this right here. Okay. So now, which means that is from, from the table, on the chart, on the procedure chart, when it's in that form, this is the one that looks like that right here, this one here. And it says, look at the z value to get the areas, add 0.5 to it. So we're gonna add, not subtract, we're gonna add 0.5 plus. Now we'll look for this on the table. Remember, we'll look for this on the table. What we found was 15.4. We couldn't find it, so we use 0.4999. Okay, so that means we're gonna add, or not subtract, add it. 0.4999. That means you add it, becomes 0.9999. Okay. Any question to that? Any question, guys? All right, since there's no question now, I guess we'll call it a day. Don't go yet. Let me check out the names. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 3 people here. Who's the iPhone? Who's iPhone?
I think it's me, Sharaya Curlew.
Okay, Shuri, okay. Okay, I got you now. Who else? I have ever a person. Kennedy, I got Kennedy. I got McCoy. Zakia. Yeah. Who is the person? Rodney, I got Rodney Jones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One more person I'm missing. Graham Matthew. Okay. 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 Dumas. I got Dumas. Got Brooks. Anyway, I think I got everybody. Harris. Harris. All right, guys, have a nice weekend. All right.
Thank you.
You're welcome.